All right, quickly in this video, I want to show you how all three different forms you can use to graph an equation that is a quadratic. We're going to talk about how to use the equations as well as how to graph them. So just a quick reminder of the things that we've talked about is this is an example of three equations that are equivalent to each other, which means that if I were to multiply these out, I would get this original standard form again, and if I were to build this out, I would get this, or if I took this and I completed the square, I would get this, or if I took that and I factored it, I'd get that. So they're all equivalent to one another. But they all have their uses. So standard form can get me my y-intercept if I substitute x equals 0 into the equation. That's because on the graph, when x is 0, that's our y-intercept. And then factored form, we can use the zero product property to find the roots. Roots are also known as x-intercepts. And by thinking about what makes all of this 0. And we set y equal to 0, in fact. What makes this 0? We set y equal to 0 because the x-axis has a y value of 0. The height of an x-axis is 0. And then vertex form, we're thinking about, there's a little bit more nuance to it, and we'll explore, hopefully you explored that a little bit when we talked about the quadratic formula, how we got that. But we think about, hey, this can give us, and complete the square to be able to find the vertex here. And that's kind of more of a phenomenon than anything else. So just a quick reminder that you might want to pause this page. I found this page particularly helpful. For y-intercept, we're going to set x equal to 0 and simplify to find the y-intercept. To find the x-intercept, we have to have something in factored form, so that might mean you need to factor it. We're going to set y equal to 0, and we're going to use the zero product property. And then for vertex form, we're going to either use one of three options. We're going to think about a line of symmetry if that's easy to find. The line of symmetry is perfectly between the roots. If that's not, it's okay. We're really going to, I'll talk about it's in option 3 and 1. They're kind of the same. And then we're going to substitute that x value in, or we'll be able to find something in vertex form. Just a quick visual representation. We know that if this is the y-axis, all of the x values along it, are 0. So that's why when we set x equal to 0, it's the y-intercept. And likewise, the same reason, but kind of backwards, if I substitute y is 0, the height is 0 all along this line, and so we can just substitute y equals 0. So here's an example of the work that I want to see. You might get a question like this. This is actually harder than the questions that you're asked to do this week, but I wanted to show you just in case, because there is some interest in it. There's some interesting pieces to it. So in standard form, remember, I can set x equal to 0 to find the y-intercept. So I'm going to go ahead and do that. I'm actually going to do it in blue. So if I set the y equal to 0, I got negative 2 times 0 squared minus 4 times 0 plus 16. 0 times anything is 0, minus anything times 0 is 0, so plus 16. So my y-intercept is actually 16. The x value is 0, the y value is 16. So I got my y-intercept. To find the x-intercepts, I need it in factored form. So I'm just going to quickly review factoring an equation. Remember, we've got the box, and we're going to think about two things. We've got the 2x squared, and we've got the 16, and we're thinking of things that add up to negative 4x, but also multiply to, what is it? Negative 2 times 16 is negative 32. So things that multiply to negative 32. So I've got, 1 and negative 32, and 2 and negative 16, and 4 and negative 8. Oh, that works because they add up to negative 4x. So we think about 4x and negative 8x. We're going to factor out. So we factor out a 2x there. That's kind of nice. Negative 4 times 2x is negative 8x. Negative 4 times negative 4. Oh no, let's go back. We can actually pull out a negative 2 x there, and then that's going to just be 4, because they both have negatives in them. And then that's just going to be a regular 4, and we got x. So my factored form is y equals x plus 4 times negative 2x plus 4. And when I use factored form, I'm going to set y equal to 0 to get the x-intercept. And I'm going to do that here. Let's see if I get a better color. We'll do that in orange. So y equals 0. So if y equals 0, then 0 equals x plus 4 times negative 2x plus 4. And we've got the 0 product property. So that either means that this equals 0 or this equals 0 for the whole thing to be 0. So x plus 4 equals 0 is one possibility, or negative 2x plus 4 equals 0. And we're just going to solve. So either x equals negative 4, so that's one x-intercept, and then or subtract 4 from both sides, so negative 2x equals negative 4, divided by negative 2, x equals 2. So those are my two x-intercepts. We've got an x-intercept at negative 4, 0, and an x-intercept at 2, 0. So that's going to help us out. All right, what do we got here? We're actually thinking about the vertex, and we know the vertex happens on the line of symmetry. And the line of symmetry is going to happen perfectly in between our x-intercepts. So this is kind of like our x-axis. There's a little y-axis somewhere in here, but we're not going to show that for now. What I want you to think about is that, hey, we've got an x-intercept at negative 4, and we've got an x-intercept at 2. Where is this perfect in between? Well, it's 6 apart. And so halfway is 3, which means this happens at negative 1. It's negative 1 is perfectly in between negative 4 and 2. Sometimes that's really easy. Sometimes it's less easy. So we need to start thinking about the vertex. And there's a few ways we can think about this vertex. We can think about it as a line of symmetry, where we're substituting the line of symmetry into the equation. But I'll show you another way to get that negative 1. We've got it. This is option 3 if you were following along on option 1, 2, or 3. We have this equation, x equals negative b over 2a. And this allows us to find this negative 1 without doing as much thinking. We can kind of just use the original equation, which was y equals negative 2x squared, minus 4x plus 16. We can use this, and we've got the a, the b, and the c, a, b, and c, and just kind of plug it in. But take note that this is negative b, and b is negative. So we've got to consider the double negative there, over 2 times a, and a is negative 2. We've got to include the negative pieces to it as well. And that ends up being 4, because it's double negative, over negative 2, which is negative 1, which is awesome because that's what our x-intercept was to begin with. Our line of symmetry to begin with. We should get the same x value. So in our vertex, the x-coordinate is going to be it's going to be 1, negative 1 in fact, negative 1. And we can use the equation that we have to find the y-coordinate. That's the beauty of functions. Y equals negative 2x squared. Well, let's do that again. X, but x is negative 1 here, squared, minus 4 times x is negative 1, plus 16. And now we're just going to use order of operations. So exponents first, and then multiplication. So negative 2 times 1 minus 4 times negative 1 plus 16. We've got negative 2, double negative, so positive 4 plus 16. 16 plus 4 minus 2 is 18. So the y-coordinate, well, this y should have come down the whole time. The y-coordinate is 18. So now we've got a vertex. This is our vertex. Our vertex happens at, and I'm going to do this in green, our vertex happens at the coordinate negative 1 and 18. One last thing, I know this is getting long, is we could have completed the square for this, but we've got to use that special rule for completing the square where we get rid of the number in front. In fact, and it's a little bit more complicated, and I'll show it here. You don't have to actually know how to do this yet. We're going to factor out a -2 first, so x squared minus 2x plus 8. I just pulled out a common factor of -2. Oops, this should actually be, because we factored out a negative, these signs change, because it should be, I should pull out a -2 from -4. I'm left with +2 so that when I go backwards it looks right. So we got our b here, which is 2. Half of b is 1, and half of b squared is 1 again. So we're going to leave everything here, -2 on the outside. We've got x squared plus 2x, leave some space, minus 8. We're going to add 1 and subtract 1. This is our perfect square part. So we've got y equals -2, parentheses, x plus 1, quantity squared, minus 9. Now here's the beautiful part, is that we can actually go back and redistribute this -2 to both pieces. So we get our vertex form, y equals -2 stuff, x plus 1 squared, minus 18. Look at this. Look at this. This is beautiful because we now have our vertex. And it's the opposite of the inside guy. So it's +1. The vertex point is -1. The y value, the y coordinate is just the outside, copied, 18. This is the same vertex as we had before. So you can choose whichever method you like the best to find the vertex. Now quickly we're going to graph this thing. I'm going to do it off on the side here. So I have all of the pieces that I need. I need my y-intercept in blue, my x-intercept in orange, and my vertex in green. Sorry, strike that. It's a little different than that, but you get the idea. All right, so we're going to graph this thing. We've got our y-intercept is at 16. I'm going to do that in blue. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. My x-intercepts are at -4 and 2. So I'm going to do that. So -4, -1, 2, 3, 4. And +2, 1, 2. All right, and our vertex is at -1 and 18. So -1, and if this was 16, this is 17, 18. All right, so we can now connect the dots. And this is going to be a little different than it was before. This is going to be an upside down parabola that goes, it has to go through all of the points that we created. And we found them on purpose. Now, I'm kind of drawing kind of a hairy parabola so that it looks a little bit better, but I hope that you can see how you can use all of these pieces to be able to quickly graph a line. On your notes this week and in this activity, I want you to graph the line and I want you to show all of this work next to your graph. Thanks so much for watching. This turned a little bit longer than I wanted to, but I think you can do it using these steps, and you get a lot of choice when you're thinking about the vertex. Email if you have any questions. Hope to hear from you soon.